Welcome to The Explainer. You know, we're grappling with one of the biggest challenges in artificial intelligence today, and that is, how in the world do we teach it to be fair? I mean, as AI makes more and more decisions that affect our lives, getting this right has never, ever been more critical.
So picture this. An AI is in charge of hiring for your absolute dream job. It can scan, thousands of resumes in just seconds looking for that perfect candidate. But what if, deep down in its code, that AI has some hidden biases? What if it prefers one type of person over another for reasons that have nothing to do with skill? This isn't science fiction anymore. This is a very real problem we are facing right now.
And it is not just about hiring, not by a long shot. These automated systems are making critical, sequential decisions all over the place. They're approving loans, they're flagging credit card fraud, and they're even helping manage public health crises. So you can see, when bias creeps into these systems, the consequences can be massive. To solve this, we first have to really get to the root of the problem.
Okay, so why not just, program the AI to be fair? Well, here's the complication. Fairness isn't some simple single concept. It's super context-specific. What seems totally fair in one situation might be really unfair in another. It's a deeply human idea, and that makes it incredibly difficult to just translate into lines of code.
Researchers usually break fairness down into two main flavors. First up, you've got group fairness. This takes kind of a bird's-eye view. It asks, are different groups, say based on gender or nationality, getting similar outcomes on average? Then you have individual fairness, which zooms way in, almost with a microscope. It asks, are two people with nearly identical qualifications being treated the same, no matter what groups they belong to?
So, how do you even measure group fairness? Well, one common way is something called statistical parity. In a hiring situation, this would basically mean the percentage of male applicants who get hired should be pretty much the same as the percentage of female applicants who get hired. It's all about making sure the outcomes are equal at that high statistical level.
Individual fairness, on the other hand, says something different. It says if you have two people, let's call them Alex and Sam, and they are alike in all the ways that actually matter for a job, skills, experience, then they should have a similar chance of getting that job. It doesn't matter what groups they belong to. It's about comparing one person directly to another based on what's relevant.
And this brings us to the crucial point here, this fundamental tension. Just because you achieve fairness for large groups doesn't mean you've been fair to every single person within those groups. And hey, being fair to similar individuals doesn't automatically guarantee fairness across the whole population. You can't just pick one. In fact, they can actually conflict with each other.
So if these two types of fairness can actually be in conflict, how is it even possible to build an AI that can handle both? Well, that's where a new approach comes into the picture. To tackle this really thorny problem, researchers have turned to a powerful type of AI called reinforcement learning. The goal is to build a system that can learn to balance these competing demands on the fly.
So how does reinforcement learning even work? Right. Think of it like teaching a dog a new trick. But in this case, the dog is a digital brain. An AI agent is put into a simulated environment, and it learns by just doing things, trial and error. It takes an action, sees what happens, and gets a reward if it did something right. After millions and millions of trials, it starts to figure out the best sequence of actions to get the biggest overall reward.
And this brings us to a specific framework called FAR-L, which stands for Fairness-Aware Reinforcement Learning. Now, the real genius of this approach is that it doesn't just reward the AI for high performance. It also gives the AI a reward for being fair. And that's a huge deal. It means fairness isn't just some rule tacked on at the end. It's a core part of the AI's goal from the very beginning.
Of course, a cool framework is just a theory until you can prove that it actually works. So to put FAR-L to the test, the researchers set up two simulations. Both were inspired by really complex real-world problems where fairness is absolutely critical.
Okay, the first test was job hiring. The AI's goal was to build the best possible team it could, but, and this is a big but, it had to do it fairly across both gender and nationality lines. The second test was fraud detection. Here, the AI needed to catch the bad guys without unfairly burdening customers from certain parts of the world with constant security checks. Two totally different challenges, really designed to push this AI to its limits.
And the results? Well, in the job hiring test, FAR-L was a huge success. It learned hiring strategies that were way fairer than where it started. And crucially, this fairness only came at a tiny cost to the overall performance of the team it hired. The test also confirmed what we talked about earlier, that sometimes being fair to groups does conflict with being perfectly fair to every single individual.
The fraud detection scenario told a pretty similar story. The framework was able to spread out the burden of those annoying fraud checks much more fairly across different customer groups. And it did all this while still being great at catching actual fraud. This result was key because it proved the framework is flexible. The right balance between fairness and performance really depends on the specific problem you're trying to solve.
So all this leads us to the biggest takeaway from the research, and it's this. There is no magic button you can press for a perfectly fair AI. It just doesn't exist. In the real world, there is almost always a trade-off you have to make between maximizing performance and ensuring fairness.
This chart kind of shows that trade-off in action. You could choose policy A, which gives you the absolute best performance, the most profit, the most qualified team, but it might be deeply unfair. Or you could go with policy B, which is extremely fair, but you'd have to accept a noticeable dip in performance. The real question is, what about all those options in between?
And that right there is the true power of the Farrell framework. Its goal isn't to spit out one single correct answer. Instead, it generates a whole menu of different policies for the AI to follow. And each item on that menu represents a different compromise, a different balance. It lets us, the humans, see exactly what we gain and what we lose with every single choice. What this really means is that the technology can't, and it shouldn't, make the final call on its own. As the researchers themselves point out, choosing the right trade-off is a human decision. It requires ethicists, policymakers, business leaders, and other experts to look at the menu the AI gives them and decide together what balance actually aligns with our values. So, we end with this question. The AI can show us the possibilities, but it can't tell us what's right. It puts the responsibilities squarely back on our shoulders. If an AI can't be perfectly fair and perfectly effective at the same time, who gets to decide which compromise we all have to live with? Maybe the ultimate goal isn't a perfect AI, but a transparent one. An AI that shows us the choices so that we can make them wisely. Thanks for joining The Explainer.